Welcome back to my channel. Today in this video we're going to talk about the power rule for exponents. So first of all, let me just say I hope you're having a great day. I hope you're in the right mindset to learn and that you're ready to conquer this concept, because you can do it. Remember that you can do anything you put your mind to. All right, so the first thing we want to talk about is the power rule. Now there's different versions of the power rule we're going to talk about. The first version we're going to talk about looks like this. And this says if I have some base raised to some exponent and I take that whole thing and raise it to another exponent, then I can combine those two exponents by, drum roll, multiplying the exponents. So I will multiply the m and the n, and then that's how I can combine those exponents. So for example, if I wanted to take 3 squared and raise it to the 4th power, so I have a base being raised to an exponent raised to another exponent, then I can just combine those exponents by multiplying the exponents. 2 times 4 is 8. So that's 3 to the 8th power. And I could leave it like that. It depends on what the directions say. It may want me to leave it like that, or it may want me to actually calculate 3 to the 8th. And you would just do that by doing 3 times 3 times 3 times 3, 8 times. And you can plug it in your calculator and get a solution. In example 2, we have a base that's a variable, but the same rule still applies. You have a base being raised to an exponent raised to another exponent, so you can combine those two exponents by multiplying the two exponents. So this will become x to the 2 times 5, which is x to the 10th power. So that will be your final solution. In this case, you can't calculate x to the 10th unless you know what x is, so you will leave your answer just like that. Another variation of the power rule is if you have more than one thing inside of a parentheses and you're raising it to an exponent, then it's almost like you're using the distributive property. So it's kind of like what you do is you distribute this exponent to each of these bases. So this becomes a to the m power times b to the m power. So you just basically apply this exponent to everything inside the parentheses. So even if you have more than 2 things inside the parentheses, if you have 3 or 4 things, you apply that exponent to everything inside of those parentheses. For example, 3, we want to raise 2p to the 5th power. So since I have more than one thing in parentheses, this exponent of 5 applies to both of those things in the parentheses. We can calculate 2 to the 5th. 2 to the 5th is 2 times 2, which is 4, times another 2, which is 8, times another 2, which is 16, times another 2, which is 32. So we'll replace 2 to the 5th with 32, and that becomes 32p to the 5th. We don't know what p is, so we have to leave it as p to the 5th. Example 4, this time we have 3 things inside parentheses that's raised to an exponent. So just like I said earlier, regardless of how many things inside the parentheses, you raise everything in the parentheses to this power. So that's 3 squared, x squared, y squared. 3 squared, that's 3 times 3, which is 9. So that becomes 9x squared y squared. We don't know what x and y is, so we will have to leave it as x squared y squared. Now example 5 is a little bit tricky because it looks like only one thing being raised to a power to another power, but there's actually more than one thing right here. This negative, because it's not inside of a parentheses, you're not raising the negative to the 6th power as well. So you will have to rewrite this as -1 times 5 to the 6th to the 3rd, which now that means I have more than one thing being raised to a power. So now I have to raise this power to everything inside that parentheses. So this will become -1 to the 3rd times 5 to the 6th to the 3rd. -1 to the 3rd, that's -1 times -1, which is a +1, times another -1, which is a -1. So that's -1. And then 5 to the 6th to the 3rd, you use the power rule that we talked about earlier. When you raise the exponent to another exponent, you multiply the exponents. So that becomes 6 times 3. So that becomes -1 times 5 to the 18th, which is -5 to the 18th. That will be your final answer. And you can actually calculate what -5 to the 18th is, or you can leave it like that. It just depends on what the directions for your homework say. But if you had to calculate that, you could simply put it in your calculator. By the way, if you want to plug an exponent in your calculator, then you'll use this key right here. It looks like an up arrow, the arrow key. If you don't have an arrow key, then you'll have a button on your calculator that looks like this. X to the Y, that's representing the exponent. You'll push this button to raise to an exponent. So that's how you could use your calculator to raise a number to an exponent. All right, the last version of the power rule that we're going to talk about is if you're dividing two things and you raise those to a power, just like previously, you take everything inside the parentheses and raise it to that power. So this will become a to the m over b to the m. And this is basically the power rule applied to a quotient. An example of applying this power rule is if we wanted to do 5 over 3 to the second power. That's the same as saying, okay, I take 5 to the second and I take 3 to the second. 5 to the second power is 25 and 3 to the second power is 9. So 25 over 9 would be my final solution. So that's how you would apply that power rule. So now I want to work a couple more examples where we use a combination of those power rules. So for this example, I want to do 2 over 3 to the second power times 2 to the third. So because I have two things inside parentheses raised to a power, I'm going to rewrite this as both of those to that power. So 2 to the second and 3 to the second. And then I still have this 2 to the third over here. And because I have a fraction times this number, I'm going to make this a fraction as well by writing it over 1. So when you multiply fractions, you multiply across. So here I would get 2 to the second times 2 to the third. And on the bottom, I would just get 3 to the second because 3 to the second times 1 is just 3 to the second. When you multiply 2, so this is the product rule, which we talked about in another video. When you have two things that are being multiplied that have the same base and different exponents, you can combine those exponents by adding the exponents. So that becomes 2 to the fifth over 3 to the second. 2 to the fifth is 2 times 2 times 2 times 2 times 2, which is 32. And 3 squared is 9. So your final solution would be 32 over 9. Again, how do you know where to stop, when to stop, or where to keep going? You just have to read the directions on your homework. So sometimes your homework may want you to just stop right here. Sometimes it may want you to evaluate all the way through. So if you were doing your homework, you could try to plug this in first, and if it counted wrong, then you would evaluate it and work it out if you can't understand from the instructions. All right, for this last example, example 8, we want to evaluate this. This is 2x squared y to the third, all of that raised to the fourth, times 3xy squared, all of that raised to the third. So since I have multiple things being raised to an exponent in both of these, I'm going to take everything inside that parentheses and raise it to that exponent, okay? So this becomes, the first one becomes 2 to the fourth, x squared to the fourth, and y to the third to the fourth. So that's from this first set of parentheses. Since all of this was raised to the fourth, that means everything in the parentheses is raised to the fourth. Now all of these are raised to the third, so now I need to take everything in the parentheses and raise it to the third power. Now x didn't have an exponent on it, so I didn't have to write it in parentheses. I just wrote x to the third power. That's why that one doesn't have a parentheses around it. Now if I go through and I just go through and calculate each of these, 2 to the fourth, that's 2 times 2, which is 4, times 2, which is 8, times another 2, which is 16. X squared to the fourth, so this is a power property or a power rule again. An exponent raised to another exponent, you can combine by multiplying the exponents. So this will be x to the 8th. Same thing here, multiply the exponents. That'll be y to the 12th. 3 to the third is 3 times 3, which is 9, times another 3, which is 27. So times 27 times x to the third. And an exponent raised to another exponent, you multiply the exponents. So now I kind of have to, it's not combining like terms, but I want to put everything together that's the same. So I want to put the numbers together. So all of this is multiplying. There are no plus or minus signs anywhere here. So all this is multiplying. So 16 times 27, those are the numbers. I'm going to put my x's together, x to the 8 times x to the third. And then I'm going to put my y's together, y to the 12 times y to the 6. And then I'm just going to work that out. 16 times 27, I have to get my calculator because I don't know what that is off the top of my head. That's 432. So now we have two things that are being multiplied that have the same base. So you can combine those by adding the exponents. So that'll become x to the 11th power because we added those two exponents. And the same thing here. You have two things that have the same base that are being multiplied. This is the product rule. Then you will add the exponents. So your final answer will be 432 x to the 11 y to the 18th. You know you can't go anymore because you don't have anything that's alike. Everything is different. So you know you're done. All right, so this is how you will use the product rule. Not the product rule. This is how you will use the power rule for exponents. If you have any questions about anything, feel free to put them in the comments below. Also, if this video helped you, if you found it helpful, hit the like button. And if you haven't already, make sure you subscribe to the channel. Thanks for tuning in, and I will see you again in the next video.